All right, welcome everybody to day 10, I believe. Yeah, day 10 of Foundation Program. We are starting our third week. We already made it through the halfway mark. So good on you guys for every single one of you guys who's been showing up and putting in your work. We started this class with 16 people, and right now, currently, we have like I think eight. So I don't know if there's still people joining. There should be because we've had more last week as well. But you can see how people kind of start dropping off slowly. Um, and that's okay. Things happen in life. It's understandable. But for those of you who have made it to most days, good on you guys. You're gonna see the fruits of your labor once you guys start foundations of programming. Um, I'm sorry, not foundation program, the immersive program or your evening and weekend program. You'll see how the work and time that you guys put in throughout these 4 weeks uh, are going to make a huge impact on your performance as well as the success rate for you guys um, in landing a job opportunity, right? Uh, the more time you guys code, the more time you guys spend behind your keyboard, the better you will become. Um, and that's just a fact. I believe that hard work will beat talent every single day of the week, regardless. But uh, hopefully, you guys were able to get some coding down or done throughout the weekend. Uh, I didn't get any messages. I said one with Mike, and we kind of handled the issue today, but uh, nobody reached out. I was available all weekend. Uh, so I figured nobody had any issues or any questions. But before we start today's lesson, does anybody have any questions about what we covered when it came to object-oriented programming or classes and objects in general? If you don't have any questions, maybe something you want to share with the group, maybe some good reading material, if you guys have, some good resources that you might have found or something that helped you kind of bridge the gap between, your knowledge in object-oriented programming, do feel free to share that with the group. Also, before I start, I do have one quick question. Does anybody or who here is doing the immersive program, the Yankee program specifically, in person? And if so, um, I have a student who reached out to me over this weekend talking about living situation. Um, he's doing the immersive program as well in person, but he's having issues about where he's going to stay during the immersive program. I'm only bringing this out so if you guys are in a position to maybe room with somebody or you think it could help you with your situation as well, let me know so we can link you guys together and hopefully find something we can work out. It's not uncommon for students to be, grouping up together while in the immersive program and just kind of splitting the load while they're there. But okay, well that's out. No questions at all. All right. So today we're gonna start our day by starting on lesson 9. All right. So last week we pretty much finished lesson 8, which was classes and objects. Um, and we're going to start today with working with importing modules, exception handling, and unit testing. And you guys kind of saw a little bit about importing modules already and how that works, whether they're built-in modules like libraries that come with Python, or by importing modules that you guys create into your own files. And we're also going to start talking about these test cases, right? Exception handling and unit testing, right? We had a question about that last Friday when we were closing off. And today we're actually going to kind of write some tests and answer those questions even further of how that works. Let me go ahead and share my screen. I did update the slides. Um, so I added the, uh-oh, what is going on? Okay, this doesn't need to be here. So I added all the class videos onto slides if you guys want to go back and have easy access instead of going through the Slack channel. And then I updated the curriculum. So today we are going through the importing modules, exception handling, and unit testing. The end of this lesson will have the lemonade stand.py, which will go up until tomorrow. It's a pretty heavy assignment. So this will probably take up today, tomorrow, and then on the 25th, if we're not done with lemonade stand.py, we'll touch up on that a bit, but then we should be able to start reading, writing files, which is pretty quick itself as well, which will jump us into an additional lesson, which is going to be the Space Invader using object-oriented programming. So we can see visually what that looks like, actually creating classes and how that's built into, you know, into a visual representation of what these classes do. And then that will be the end of pretty much anything involving object-oriented programming, right? After the Space Invaders assignment, we won't be touching classes and objects. The next thing we'll be doing will be data structures and algorithms. So talking about big O, common problem solving formulas. I don't know if you guys heard terms like, searching, sorting, recursion, the common patterns that people use when it comes to solving like your LeetCode problems, right? So we'll talk about some, commonly used algorithms that you guys can add to your tool belt to start actually taking care of these LeetCode problems, right? I'm sure probably up to this point, for those of you who gone to LeetCode, you kind of just shoot in the dark, right? You kind of trying to hoping for the best, seeing what works, with no real game plan or structure. But there's actually a secret to almost every single, if not every single problem that is on LeetCode or Code Wars. There's a trick to it, right? And that trick is trying to find the pattern, right? Pattern recognition um, and using the most effective algorithm to solve the problem, right? And we'll talk about stuff like that, as well as some additional stuff like touching up on regex, right? It won't be an in-depth class, just enough to get you familiar with it, and then a quick touch up on ASCII values. And then finally, the remainder of the class will be touching up on the pre-work challenges that we did, that you guys did, trying to get here, and it's seeing how far you guys have come from day 0 to now, right? How much more effective programmers or coders you guys have become. But without further ado, let's go ahead and start lesson 9, importing modules and exception handling, as well as unit testing. I am a little sick, um, so if I sound a little congested, please don't mind me. So what is a module? A module is just a normal Python file that contains definitions of functions or classes that you would like to use in another file, right? And we saw a representation of that while working on the streaming guide, how we separated the different classes and objects. We, when you have a file with multiple classes and then you're instantiating all those classes in the exact same file, it can get very congested. It can get very difficult to read, and then it involves a lot of scrolling left to right. So we went ahead and we separate those concerns by adding these classes into different other files, and we imported them, as modules, right? And you guys kind of already saw an example of how that worked. Here on this code snippet, we have two files. We have the main.py, which is kind of the standard naming convention for what we call like the main file that's supposed to import all the other modules to use when needed. And then we have a mystats.py, right? So the mystats.py is what's holding a function, right? Which is finding the mean of a list. This function creates a variable called sum, then loops through the list while adding every single number within that list into the sum variable, then returning the sum divided by the length of that list, therefore finding the mean, right? That the mystats.py itself is the module, and then we import it here in the main.py on the bottom code snippet. All right, we have import my stats, as you guys recall, and I'm going to be reiterating some of the things I say, just to make sure that Owen here, since he wasn't present here last week, is kind of up to speed. Uh, there's two ways of importing the module, right? We can import the entirety of it by just doing it as we see here in this code snippet where we say import my stats. Uh, they just imported the entire module called my stats. And the problem with that, Owen, sometimes is if my stats has multiple different uh functions and classes, by just doing import my stats, the entirety of that file name, you would import everything within that file, right? Therefore, you would have access to all this other stuff that you might not actually need. Um, so what we did when we wanted to specify exactly what we want to import, we would do from my stats import find me, right? So what that is saying is, hey, from this file, import this function, right? From this file, import this class. That would keep us from importing the entirety of that module. Just import exactly what we need. Let me kind of open up a, uh-oh, don't look. That is the answers to elimination of pi. Uh, you might see the answers in today's video when I upload it. Clear. Give me a second. I should have prepared for this. I don't know why I didn't have it up. I was a little busy before class, but this was from yesterday's code. Owen might be a little overwhelmed by looking at this. He's like, what the heck is all this? Uh, this is from yesterday's. This is what you got to look forward to, Owen. I see your eyes pop up. It's not too bad. Let's close this up. Let's open up our lesson 9 and let's start a new file here. All right, we're gonna call this module. We'll call it main.py, right? This is our main.py, and then we can do another file which is gonna be functions.py. That shouldn't give me an error, right? And this is gonna be the module that we're creating. We'll do something simple, not even me. We'll do for define sum, and it takes in num1 and num2. Sum is equal to num1 plus num2, return sum, right? And then
Quick question.
quick answer.
I'm assuming def is essentially the same thing as function.
Correct. Oh, so you missed a lot. That's right. So we did start the Python crash course last week, right? And we are working strictly Python. Everything that we did last week is Python. The way the syntax for Python when creating a function, whereas if you recall JavaScript, you would type in function and then the name of the function. Here, it's a little bit more English, so we would just use def for define, right? We want to define this function. Notice that this function is not taking open and close curly brackets to
Yep.
start the code block. It uses the open close parentheses and then a colon to start the code block. And the way that the code block is separated, where you know where it starts and ends, is by the indentions, right? So after we define some, everything that's within this function is indented to the right, and the start point is after this colon right here. If you wanted to finish working on this function and get back to your regular global scope, then you would just unindent and continue coding as normal, right? So we can do define, we call this, let's call it subtraction. Subtraction, num1, num2, and then answer, whatever, is equal to num1 minus num2. Return answer. Right. Notice that after we were done with this function, we just unindented and we can continue with our code as needed. right, going back to the main.py. So we saw how to import the entirety of a module, which was import functions, right? Just the name of the file. And the reason why is this, you just go import and just type in strictly just the name of the file right now is because that file is currently within the same directory as main, right? These are in the exact same directory. What directory is this? It's lesson 9. So because the main file that's importing the module file functions are all located within the same directory, we don't have to add any crazy stuff like a dot / right? Telling it whether it's a level below or a level above. We just go ahead and type in directly the name of the file because they're within the same area. If for whatever reason the module that you're trying to import is somewhere else, like let's say in lesson 5, you would have to specify the pathway for that, right? Of how to get there, a file above or a file below, yada yada. So we were able to import the entirety of functions.py, but notice there's 2 methods in here and we only want 1. So we would do from functions import, and then you would give it what you want to import. I want to import sum. So it would look like that, right? So from functions import sum. That way we just grab exactly what we want to import without bringing all this other useless junk that we don't need right now.
Thank you.
No problem. Another thing that you guys might seen is as, right? So sometimes you might have modules that have some weird names. A good way of importing stuff is giving it an alias. You can do stuff like this, right? Let's say we could say import functions as f, right? If you wanted to import the entire of a module, but let me backtrack a little bit. You have sometimes there's modules or methods, or sorry, not modules and libraries that have weird names. An example of this, if you guys have ever heard of the Python library called tkinter. Tkinter is a Python library that you can use to create graphical user interfaces. We're using Python code, right? And it comes with some built-in methods. Well, whenever you want to use these methods, you would have to call the name tkinter dot whatever method you're trying to create, right? And that kind of gets very repetitive, especially when it has such an odd name like tkinter. Nobody wants to keep typing in tkinter. So you can do, instead of doing import tkinter, which would just import the entire the module, using the tkinter name, you can do import tkinter as tk, right? And I'm gonna use a quick method here, which you guys don't need to be familiar with, but just know that tk.tk, right? Because I imported the alias, I was able to type in tk. If I didn't have the alias, I would have to type in the entire module name to use any of its methods, right? So notice here that I call the library that I imported, and then I use one of the methods that it has, right? And we see that with stuff like math.random. When you import math, you have to like use math.random. Well, you could import it and then give it an alias, so you don't have to keep typing in math, right? Such a long word, right? I mean, this example is not a perfect fit, but there's some weird libraries out there with some weird names that you don't want to keep typing out, that name, and you can give it an alias. So when I import it, I can say as tk, and notice that tkinter is no longer being recognized because I changed the name of it when I import it. So you're able to import stuff and then give it an alias, so you can call it for whatever you want to create. It makes it easier when you're coding, so you don't have to keep repeating yourself, especially when they have weird long names, right? Naming conventions. Nothing major here. I just wanted to make sure you guys are aware that this is something you will see. If you guys are going through tutorials and see people doing this, that's what they're doing. All right. So we're able to import certain things as certain alias. Let's say our functions module has not just 2 but 10 20 different functions, right? But we want to import a handful of them, but not the entirety of it, right? And you want to do from functions import sum, and then you want to do from functions import subtraction, right? You can import multiple things just by adding a comma, and you can import multiple methods in that manner from the same function without adding multiple lines, right? So you can separate it with that comma, and that allows you to do that for you, right? Cool. So they imported the my stats, right? And then they created a list in this code snippet called some li, some list, added a random numbers here, in no specific order or range. And then they created a new variable here called mean val, probably for mean value. Notice that they call the module they imported my stats, and then they use dot find mean. Well, once again, back to the math example, right? When you guys import math, you have to call the module name and then use a dot and use the actual function that comes from that module. They're doing the exact same thing here. They're doing my stats dot find mean. And like I said, if you have weird names, you get very repetitive, especially if you have to use that method multiple times. So importing either the function directly or importing it as a certain alias can help remove some of these unknown little things, right? But by doing this, they had access to the mean function from the module, and they're able to use it in the main.py. All right, importing specific functions or multiple, right? So here we see from my stats. Oh man, I recovered this while even looking at the slides. So they're specifying again what they want to import from my stats. So they do from my stats import find mean. And notice they no longer have to use the my stats dot find mean because they didn't import the entire module. They just imported the function. So they had access to that function. So on line 3, they didn't have to do the my stats dot with the where I'm looking for prefix, right? They just use the find mean. On the bottom code snippets, you can import multiple functions and or classes from the same module like this. We see from my stats import find mode, comma, find mean, comma, find median, right? So importing multiple different functions from the exact same module, just separate them with a comma. All right, importing issues. If I import the following module and run this file, I get 15. Why? All right, so let's kind of break this up. We have, oh, they gave the answer already. Oh, God dang it. All right, so we have main.py, and they're importing calculator, right, within the main.py. Well, let's look at what calculator is, right? Calculator here has two functions, which is define, and then mult, right? So they're multiplying, and it returns the product of two numbers, right? It returns num1 multiplied by num2. Then we have the add function, which is taken into two numbers as well and returns these sum of them pretty much. And then within the exact same module, right? The calc.py, calculator.py, that is the module. They write some code. They do result is equal to mult, and then they pass in the two arguments, 3 and 5, and they print out on line 10, right? The result. And notice on the main.py, when they import it, they're not doing anything else, right? On the main file, they just imported the module. But for some reason on the console, there's a 5. Well, that means that somewhere within the module they imported, there was some code, right? It ran it as a script, right? That they imported, the code ran the moment it was, we ran the main.py. And we're going to talk about how we deal with that, right? And this is probably something you guys have seen for those of you guys who have been stuck in tutorial hell. The main functions, right? If the file is imported, underscore underscore name underscore underscore will equal the name of the module, and the file will be executed. If the file is run as the script, then underscore name will equal underscore main, so the script will run. That's very confusing. What the heck did I just say? Let's break it down. Right? Going back to our example, right? We have our functions.py and we have the main.py, right? So let's go ahead. I'm just gonna go ahead and import functions. And this won't do nothing right now. Right now, functions only has the declaration of these functions, right? So when we run main.py, nothing's gonna happen here, right? Let's go ahead and cd into it. Python main.py. All right, I run the file, nothing happens. My console is empty. Now, I imported the functions, right? So there should be access to it. Within the functions.py, all it is just functions being declared. But within here, I'm gonna go ahead and use this just like the example did. Result is equal to sum, pass in 2 and 4, and then print result. Right? We're actually doing some coding here. We're actually using these functions within the module. Well, let's go back to our main file where we're importing our functions and run that again. Notice that 6, right, is being printed out. Well, why? We import the functions. As far as we know, it's just a module with a bunch of different functions, right? Well, it turns out there's some extra coding here. Well, let's print something out. Let's print out print underscore name underscore. Let's see what that looks like. I think I might have messed this up. We'll check it out. Okay, right. So when I run the functions.py file, notice I'm not running the main.py, right? The main.py isn't running right now. I just ran our module directly, right? Let's remove this code, right? This module right now, as it is just nothing but functions. I'm gonna go ahead and run it. Nothing happens. Well, of course, nothing's happening. The only thing it's doing is declaring functions, right? Let's go ahead and uncomment line 12, which is gonna print underscore name underscore. This is what's gonna confuse you guys, but we'll figure it out. It's gonna print out underscore main underscore. Now, why is it doing that? Well, it kind of reading the name of the file, or it kind of checking how it's being ran. I guess it's a way of explaining, right? Underscore main refers to what's being ran, right? If functions.py is being ran as a script, is it being run independently? But what does it mean to be run as a script? It means, is it being imported somewhere else and then being ran through a third-party file, or are we running this file individually, right? And if we print out name, it's going to give us main, right? What that's telling us, right, that this file is being ran individually, right? When you import it into a different file like main.py, it's no longer going to be called main. It's going to be called something different. I'm not quite sure if I could do that here. Print. Let's go. I wonder. I don't think so, but let's see. If I run main.py, okay, so import that. Let's go ahead and do this too. Okay. Right. So on the functions.py, I'm doing print underscore name. And the main.py, I'm running the same thing, print underscore name. Notice that when I run the main.py, I get two things being printed out. I get one thing being functions and one thing is being called as main. Well, which one's which? Well, let's try to differentiate this. In the main.py, I'm going to also print something else. I am main.py. And then within the functions.py, I'm going to also print out I am functions.py. Right. Now let's go back to the main.py. Notice they're both printing out main. Right. They're both printing it out, but I want to figure out which one is running which. I'm only going to run main.py. Right. I'm running main.py and we see something here. We first get functions, I am functions.py, and then we get main, I am main.py. Well, why is that happening? Well, when I run main.py, the first line up here is import functions. So all of imports is going to run, right? After that runs, it goes to the next line, and then line 3 is being ran, and it's I am main.py, which is why the functions.py is being printed out first, and then the main.py is being printed out second. But notice that they're both printing out underscore underscore name, but on that section, only one of them is printing out main, while the other one is printing out the word functions, right? And it goes back to where that module or that file is being ran in, right? When I did print dunder name, right, this method right here, and I ran the main.py, this returned to me as main because this file is what's being ran, right, independently. Functions didn't give me the dunder main, right? Dunder stands for double under, Owen, so I stopped saying underscore, right? Right. When functions ran, it didn't give me dunder main, it gave me functions because functions wasn't being ran independently, it was being brought in as the name functions, right? Whereas the main.py, it was ran independently. That's the main file that's being ran right now. It gets the default name of main, right? And what that is saying is pretty much checking how is this file being ran? Is it being ran individually? Like this is the individual sole file being ran, or is this file being imported somewhere else and being ran as an import, right? That is what main says. And we're going to talk about something that you guys kind of seen, probably more than likely. You've seen it here or there within YouTube videos. You've probably seen if dunder name is equal to dunder main, then I want to run main function. And what is that? Well, it's essentially a function that is going to check how a code is being read, right? Within my functions.py, I have my result variable. I have some code being ran here, right? But I don't want this code to be ran whenever I import it. If I import this function, this shouldn't be ran. I should only have access to this stuff, but this shouldn't just run automatically. I only want to run this code automatically if I'm running functions.py just solely on itself, not as an import, but I'm just running functions.py individually. And the way that works is by creating a main function. Define main. Right. And then within this main function, you can put all the code that you want to run if you ran functions.py individually. Right. And then you add something like this. If underscore name is equal to main, then I want to run main. Have you guys seen this yet?
Yes.
What the? I knew someone saw it. Good job, Mike. Right. So what this is saying is, hey, if my name is equal to main, that means that I ran functions on its own. Right? When does name not equal main? Well, we just saw it does not equal main when we import it, right? The name changes to whatever is being imported as, right? We printed out name and it came out as functions because we imported it as functions. That means this line right here will not run if functions is being imported and then ran. But if functions isn't being imported and I'm running it on its own, then this is going to equal to main, right? Because we saw that main only comes out when it's being run individually, right? So it's gonna get to this line. Hey, is name equal to main? Am I running this file on its own, or am I importing it somewhere else? Well, hey, I'm running on its own. Therefore, I'm going to go ahead and run this method called main that I defined up here. And we see it here when we run the functions.py on its own, it actually gives us a 6, right? But when we run it here in main.py, we no longer have the result being ran when we run import functions. The only thing that's being printed out is line 3, right? So any additional code that is within my modules that I don't want to run individually, we put it within a main function. So when it gets imported, it doesn't run automatically, right? Does this make sense, guys?
Can you repeat that? Can you say that one more time? That last part about what's the
Yeah,
very last-
so earlier when I didn't have this part, right? And I didn't have this main function declared, I just had raw code, right? And I ran my main.py. We see it when main.py runs, it's running something here. It's printing out 6. Well, 6 isn't within my main.py. It's within my functions module, right? It's automatically running all the code in here, but this shouldn't be running like this, right? So to avoid that, we put this within a main function, and we set the condition. If name is equal to main, then I want to run the main function, right? And what that does, it keeps the functions.py automatically running useless code that doesn't need to be ran when being imported as a module, right? Right, when we run main.py, it no longer prints out that 6 that was within functions.py. It's only running whatever main.py has, even though we're importing functions, because we set the conditions within functions that this will only run if the functions.py is being ran individually, right? That means that if we import the functions module somewhere else and we run this file, import function isn't going to give us no weird code or no weird functionality where it's running some code that was within its file, because it's all added within this code block of main, right? It's just essentially checking if the functions.py is being ran on its own or it's being imported somewhere else and ran through a second file, right?
So I have a
That-
question for you, Rodney.
I might have an answer.
What would be the purpose of wanting to put the name variable in the module? I'm just saying, as far as from a real case scenario.
Yeah, I mean, it depends what you want to do with this module, right? If let's say it's a script that's supposed to be doing something, right? This script, it only should run all its functionality when you run it individually, right? But let's say you're creating this other program that could take advantage of some of the functions you have in the script, right? So you want to use those functions, but you don't want the functions.py to run its entire script and do what it was meant to do initially. All you want to do is get access to certain methods and functions, right? So that's when you can probably use the if underscore name, right? If I run this file on its own, that means I'm going to use it as a script to do something. It has some functionality. It's going to take whatever is within the main.py and run it. But if I'm importing somewhere else, I probably don't want it to run and do everything that it should be doing. I just want to grab some stuff in there, right? It shouldn't be running its main file or its main function on its own. Does that make sense?
Yes, I am seeing what you're saying. Yeah.
Okay.
Thank you.
No problem, brother. All right, so back to this slide. Hopefully it makes a little bit more sense. If the file is imported, name will equal the name of the module and the file won't be executed, right? So that means, just like we saw in the code snippet, I imported functions. So when I run that file, it's not going to equal to main because it was imported as functions. If the file is run as a script, right, on its own individually, then name will equal main, so the script will run, right? We will see this script right here, like its own individual code, actually running and doing some kind of functionality, right? But when you import it somewhere else, it won't do that because of this code block of define main. Make sense?
Roger, so we still could use all of those functions? We just
Yes.
wouldn't see that we're calculating
Yes.
the function, call the function. Okay.
Line 10 and line 11 won't run, right? They won't be doing all these different stuff, like running on its own, setting a variable, printing stuff out. This won't run, but we can still access everything else.
Okay,
Right.
thanks.
No problem. All right, guys. Now, module student practice basic stats. So go ahead and open up your repository, go to lesson 9. We're gonna go to the basic stats folder. And it should be an empty file, but let's look at the readme, right? For this project, you will import the statistics module, right? You're gonna write a class called student that has 2 private data members, right? The student's name and grade. And it should have an init method that takes 2 values and uses them to initialize the data members. It should have a get grade method, right? And then I want you to write a separate function, not part of the student class, called basic stats, that takes as a parameter a list of student objects and returns a tuple containing the mean, median, and mode of all the students. To do this, use the mean, median, and mode functions in the statistics module. And we see here a link for you guys. You guys can come here. This brings you to the math stats functions, right? We see here a small example from statistics, import median. They're even importing stuff from math and either tools, whatever. And then they can use these methods in here, right? Down here, we can see a bunch of other ones, mean, F-mean, stuff that I never learned in high school, median, multimode, yada, yada. All right, you can see all these different functions and kind of check it out. Your basic stats function should return those 3 values as a tuple in the exact order given above. And as an example, your code should be called as follows by the grader, and you kind of see it here. All right. I'm going to break you guys into groups. And mainly because I got some people here that probably aren't up to speed. So that way they kind of watch you guys. Who here feels very confident with this and can kind of share the screen with their group and kind of talk through what they're doing? You don't have to feel confident with the assignment, just feel confident with classes and objects.
I feel confident enough.
All right, Mike, we're gonna do that. I'm gonna break you guys into groups. What you call it? Not too big groups. That way you guys kind of work together. And then I'm gonna stay here in the main room. I'll give a room to Brandon. You guys are more than welcome to bounce around to our rooms if you guys feel like you might need help or you're stuck. But that way we can kind of give some one-on-one help or bounce around and see how you guys are doing, and you guys can collaborate with each other as well, okay? Let me go ahead and stop the recording and we're gonna break off the groups. All right, hopefully you guys were able to get some good work in, especially working in groups. So we're gonna go ahead and do a code along and talk through, right? So for this project, we had to import the statistics module. Can you guys all see my screen? All right.
Nope, we just get to see you.
Awesome, awesome. There you go. Good, good.
Yep, we
Awesome,
do.
guys. Go away, Norton. All right. So here we go. So from top on the README, we're gonna import the statistics module. So import statistics, right? And we had to write a class called student that had two private data members, right? The student's name and grade, and then it should have an init method that takes two values and uses them to initialize the data members. It should have a getGrade method. All right, so let's go ahead and declare our class. So in Python, to create a class, we start with the name class and then the name of the class. This will be called student, and just like before, when we name our class, it has to be in capital letters or essentially after the first word in camel case, right? So capitalize student, and then we have to define our init method, which pretty much every class has. And this is what's going to initialize our class when we create an object, right? This is where it reads to kind of assign our data members. So we define that by using define underscore init for initialize, and then underscore. And then we have to pass in self, because self is what it's going to use to reference the class. That's just standard when it comes to classes. It always has to have self. And we see here that it has two private data members, right? It's supposed to have the student's name and grade, and it's supposed to be passed in as values, right? So we're gonna give it name and grade. So once it gets its argument in there, we can actually go ahead and start defining the data members. So like everything else, we started with self. Because it is a private data member, we have to put an underscore after the dot so we can privatize it and keep other people from getting it. And you'll see this later in the recording, Owen, of why we privatize stuff and how that works. But just know to privatize something, you put an underscore. If this wasn't privatized, it would just look like self.name. But we're making it private, so we put an underscore here. Right, so self._name is equal to, and then we assign the value that we got from the arguments. So it's gonna give it name. Name's gonna next gonna be the grade. I'm passing grade, right? So the student's name and grade. It should take two values and use them to initialize the data members. It should also have a getGrade method. Well, why do we have a get method, Owen? Well, we made the data members grade and name private, but we also have to have a way to access the information if we want to be able to, kind of read it, right? So we define a method after the init method is complete, and this is what we call a getter method, and we'll call it getGrade. This will take in self like before. It's not going to take any other parameters. All it's going to do is return whatever self.grade is, right? So return self._grade, right? Then we have to write a separate function that's going to be not a part of the student class, and it's going to be called basic stats. So we're going to go ahead and come down here, unindent, and we're going to define basic stats, right? That takes as a parameter a list of student objects, right? So we'll say a list of student, I'll just say student object list, student object list. All right, so we know what it is. All right, a list of student objects and returns a tuple containing the mean, median, and mode of all grades. All right, so we have to write some notes here. Return the mean, median, and mode of all grades. All right. Let's get our examples down here of the students that we instantiated. Let me put class here so I thought getting an error. I'm gonna go ahead and create these classes down here, so we kind of slowly start working with them. So notice here, Owen, we have 4 different variables. We have S1, S2, S3, and S4. Each one we're assigning them a value, and the value is an object, right? We're calling the student class, just like how it's defined student, and then open and close parentheses. And notice that we pass in 2 different values. What values are these? Well, as you see here within the student class, we defined it that's supposed to take in a name and a grade. So each one is supposed to take in 2 different values. Kayomi is the name, grade 73. Mercedes, the name, grade 74, and so on and so forth, right? Once this is ran, this creates an object, and this person has access to this information as well as their stats, which we're about to, I'm not, disregard what I just said. I like, not the stats, get grade. Why did I put mate? No one corrected. Get grade. You guys are just as blind as I am. All right, you guys are supposed to be like watching me code and no one says anything. Just waiting for me to fail and get an error in the console in the middle of the recording. All right, so we got the objects, and how is it that's supposed to work? It's supposed to take in a list of different people, right? Let's create that student list. Student list. Uh-oh, there we go. Student list. Remember, guys, list we define it by open and close bracket, and we just put in S1, S2, S3, S4. S1 shouldn't be here. They're never available anyways. Next, we're gonna go ahead and look at the basic stats, right? It's supposed to take in this list, and then what it's supposed to do? Return the mean, median, and mode. Well, I suck at math, so I'm gonna go ahead and open this bad boy up and see how do we calculate the mean, right? Okay. Could you just use the mean method? How does that work? Let's open it up. So notice that the mean, it takes in a list of integers and then it returns 2.8. So just by using this method, we can do the mean was what? There's no decimals here, but it added all these up and then divided by 5 and it gave us 2.8. Okay. Well, to get the mean of the grades or to do anything with the grades, we're going to have to loop through this list, right? So we can grab every single object. And then once we grab the object, we have to grab their grade, right? Well, how do we grab their grade? Well, luckily, we know that we created this variable called get grade, and it returns to us the grade data member that they have, all right? So within the basic stats function, we're going to do all grades. This will be a list that we're going to create. And then we can add the grades in here. So there's two ways of doing it. We can loop through. We can do for student and student object list, right? This will grab every single object from this list. And as we grab every object, we can use the methods that they have. So we can use student dot get grade, right? This will return to us whatever grade this object has, right? And then we can add this into the all grades list. So we can do all grades dot append. How do we add things to a list in Python? We use the dot append method, Owen. Whereas in JavaScript, you recall there's like push, right? To add stuff to like the array. Well, here we use append, right? And append's gonna add this to the list. So by doing student dot grade, this is going to return to us the grade that belongs to that student. And then as we grab the grade, we're adding it to the all grades list. That'll give us everything we're looking for. Or we could do some list comprehension. And this is also in your slide going. We could do student dot get grade for student and student object list. That's pretty much the exact same thing I just did, Owen, with a for loop. But instead of writing the extra code on separate lines, doing the for loop, I just instantiated this list right off the bat by adding what we call list comprehension, right? I essentially notice here for student and student list, this is the exact same syntax that we saw there on the for loop, right? And for each student that we grab, we're doing dot get grade. Don't let this confuse you. All right, just know this is the exact same thing as doing a for loop. All I did was I one-lined it, which is it's typically like a more advanced thing. But I'm showing it to you guys in case you guys see it in other people's code. You're aware of what's happening, right? essentially we have a list right now that holds all the grades of all these little runs, right? Now, let's see what their mean is. We're gonna go ahead and do mean is equal to, well, we saw it's the statistics dot mean method. So we would have to do statistics, right, dot mean, or we can add an alias. Remember, I hate typing stuff that I don't have to type. So import statistics as S. So instead of statistics, I can do mean is equal S dot mean, and then pass in the list of grades. Median is equal to S dot median. What's the next one? I believe that's how you do it. We have to get the median and mode. So we got mean, median, correct, and then mode, right? So it's as simple as that. We can do mode is equal to S dot mode, all grades. All right. And that gives us what we were looking for. But then how do we have to return it? Right? It takes in a parameter, as a parameter, a list of student objects and returns a tuple containing the mean, median, and mode of all the grades. Do this using mean, yep. All right, well, we can do something as simple as this. Or do, grade tuple is equal to mean, median, and mode. That's simple. All right, return tuple. Cool. We can get rid of the pass. And now we can print out whatever basic stats is with the student list within it, right? So essentially we're calling the function we created, right? Basic stats, it takes in a list of objects. We already declared that earlier, right? We create these objects, added them within the list, passed it in as an argument. It returns a tuple, but it's not printing out anything within the function. So we have to print here. And then we can run this bad boy. What lesson is this? Lesson 09. Delete that's. All right, we get class tuple. Why do you do that to me? Oh, I'm dumb. Return grade tuple. You guys really don't want me to succeed. Why don't you guys show me that? I just typed in tuple, not grade tuple. All right, let's go ahead and do that again. Print it out, we get 74.75, 74.0, and then 74. Is that what everybody got?
Yes, sir.
Awesome. Pretty straightforward. Good job, guys. We're going to take a 10-minute break because I don't know if you guys took one while I'm on the breakout rooms. That lets you guys get some coffee before we get on to the next class. And I will see you guys shortly. My wife still works in the National Guard. She's like active guard, right? And she gets free stuff from the guard. Like I didn't know how much stuff the guard gets. And they gave her 3 24-packs of like Prime energy drinks. So I got like 16 energy drinks in my fridge right now. It's so nice, dude. So nice. And then I'm at home like a bum, sleeping till like 3 p.m. Playing video games all day while the lady works. Being a civilian is so nice, guys. So nice. Highly recommend. 10 out of 10 would do again.
You been out for how long now?
Close to a year now. Getting close to a year now. It's been super nice. I served 8 years in the Army as a combat engineer.
Okay. Nice.
Mm.
I was in the Navy 4 years.
Do you like the Navy?
Yeah, it was good, bittersweet. I served from 2000 to 2004, so it was good.
I got any 80-second cats here? Any paratroopers?
I've been airborne. I wasn't in the army though. I was in the Marine Corps.
You went to airborne school as a Marine Corps?
Mhm.
How'd you get it? Like a re-enlistment incentive?
I was a recon Marine.
You're a recon Marine. Look at you, dude. That's pretty cool. Dang, all right. Why you getting out? You made it.
It destroys my body.
You ain't wrong, dude. You ain't wrong. All right, guys. Let's go ahead and move on. So we just finished basic stats. Next, we're gonna go into um exception handling. And go ahead and share my screen. That's pretty much all that we're gonna talk about when it comes to imported modules. There's not really too much to it. You guys kind of already did it on your own, honestly. Justin did it on his own right off the bat, cheating. But you know, it's not too difficult, like to kind of get the hang of it, right? I'm sure as you guys already seen. So, next, we're gonna go into exception handling. Can you guys see my screen? Yes. All right. So two things that will stop your program and print an error message. I'm sure you guys have seen these. Syntax error, right? You forget a colon or a misspelled, right? You misspelled something, right? Exceptions, all the other errors that stop your program and print an error message, right? Maybe your function didn't get a necessary input or something was not defined. But instead of allowing exception to hold a program, you can write code to handle the exception, right? Almost like overriding it, kind of in a sense. And that's what we're gonna get into, right? We're gonna talk about try and except blocks. Now, this isn't like anything crazy. This is like, you know, some like small level like exception blocks, but this is enough to kind of get you an idea of how it's working. And kind of dip your toes in the water. All right, so here, let's talk about this code snippet. We have a variable called numerator, where we're doing 10 to the power of 3. The two asterisks are to the power of Owen, right? One being just regular multiplication. Then we have a denominator, which we got from the input from the user, where we say enter a number for the denominator. Notice we have integer wrapped around to ensure there's no some weird comparison between integers and strings. And then we get to the actual try and except block. We're going to try to do lines 5 through 6, and then line 8 will run if we get this error. Right, so we do try, result is equal to float, and then they essentially what they're doing is converting numerator divided by the denominator into a float and then printing the result. And then the except is the 0 division error, which pretty much is to print out division by 0 is undefined, right? Let's see this. Let's see it in action. Let's go back to our main.py. Erase this bad boy, erase function.py. We don't need function.py. So within our main.py, we're going to go ahead and get this. Let me move this to the side. We have numerator is equal to 10 to the power of 3. We have denominator is equal to int input enter a number for the denominator. Awesome. Next is our actual try and except block. So we're gonna try to do what's within line 5 and 6, but in the event it doesn't happen, I want to run the except block. Right? Result is equal to float numerator divided by denominator print result. Actually, let's do it without the try block. So without the try block, we're gonna go ahead and run our main.py. Enter the denominator. What was their example? 5. Enter number for the denominator. Okay. So we got the correct answer. Now let's do 0. And we see here, all right, without the try and accept block right off the bat, it gives us an error, right? We have no try and accept block here, right? We just moved forward with actually creating this result and then printing the result. And we see trace back. It tells us what line it came out of, right? It tells us the file, and then it tells us what it was. Result equal to float numerator denominator, zero division error, right? Division by zero. So zero division error is a built-in error message that comes with Python, right? It's tracking. It's a known error message, right? So when we create our try and accept block, we're not just pulling zero division error out of thin air. It's an actual error message that you can encounter. And you can Google all these error messages if you want to be able to catch some of them, if you want to be more familiar with them. But it is a known issue. So let's go ahead and bring this back to how it was where we did a try and accept block. We already know it's going to fail, right? If that happens, but I want to be able to catch it when it does happen. So this is saying the try and accept block is, hey, I want to try everything within lines 5 to 6 within my try block. But if I run into an issue, right, it's going to exit out of my try block, and then it's going to go to the accept block. It's going to check the accept block. Hey, is this a zero division error? If it is a zero division error, I want to run line 8. That's what line 7 specifically saying, except if I get a zero division error. If it's not a zero division error, line 8 won't necessarily run. It's because it's only catching the zero division error. Let's say there's a different error, right? We're trying to catch the zero division error, right? But if it catches a zero division error, I want to print out my own customized message. I was going to say something I didn't want to say. I caught you. All right. So I caught you. Let's run that again. Enter a number, and we see it. I caught you. So instead of getting the console screaming at us like we did earlier, it told me like I caught you, right? Let's make it a little bit more professional. Division by 0 is undefined, right? And at 0, notice that it didn't yell at us. It didn't stop the program, right? And that's what's important here. It didn't stop the program. It didn't give us no issue. It continued everything and gave us that. Let's say, print hello. Right, 0, hello. Now let's get rid of this and this and bring this back. Right, notice what happened. What happened when I took out the accept block, the try and accept block? It ran to an issue on line 5. It yelled at me, telling me zero division error, division by 0, and it never got to line 9, right? It halted my program. And that's where try and accept blocks really come into play, or honestly just handling errors in general, is being able to keep your program from completely halting, catching stuff, identifying it, but still have everything else continue, right? That's the purpose of doing this. All right, next. So
Can I ask you a question, Roger?
Yeah, go ahead.
On line 7 where you've got zero division error, do you have to have the exact right error there? I mean, do you have to figure out which error to put there that fits with your situation?
Essentially, yes, right. You can kind of, I mean, if you're coding something, you would think to yourself, how could this break? And this kind of comes into your own coding practice. Like when you guys start making your programs, you start thinking to yourself, okay, well, now that my program's complete, how can somebody else mess this up? Right? Because that's what happens, right? People will mess things up. They will add stuff that shouldn't be added, right? They might add a string, right? So you might want to handle what happens if they add something that's not a number, right? Or they might add a number that's too big for what you're looking for, right? They might add a character that just shouldn't be there, gentlemen. The point is, people will always find a way to, dare I say, fuck it up, right? So it's up to us to handle what could go wrong. And that's when it comes to you guys, like, okay, well, what could happen? Well, what if they added 0? And then it will be up to you, like, okay, well, how do I catch 0? Is there an error for catching zeros? Or, just like I did it earlier, right? I went and I tested it. What happens if I add a 0 and it yelled at me? Oh, okay. Well, I don't want my program to stop, right? This comes from me like testing my program out. All right, let me go test out the functions I'm creating. I got an error for here. Let me go ahead and look up how can I, find these errors, right? So you go and you test it by adding zeros, by adding strings, by adding floats, by adding an absurd amount of numbers, by adding an empty string, right? By adding characters that shouldn't be there, and then you start getting these errors. So that, okay, so I see here that when I added 0, it gave me a 0 division error. So let me do an except block to catch that 0 division error. And that's kind of how you find, like, you come to these conclusions, right? You're not just gonna start coding it like these are all the possible errors that I might have, then start trying except blocks, right? Unless you're, just you're him, right? But that's not us. So we, uh, through trial and error, testing your code, uh, you know, quality assurance testers, like that you will run into these problems, and then you kind of go back and you fix them. But yeah, that's kind of how you come to these conclusions. Unless I mean, if you've been doing this for a long time as well, you are also experienced the fact, hey, these are the errors I run into constantly. So let me kind of mitigate that by adding it now, and that comes with experience. But does that answer your question?
Kind of. I'm assuming there's a list of errors, and my question was like, you have to choose one of those. It's not like you can make up your own error, right? Is that? I guess that's my question.
We will get to that in a bit. There is ways to raise our own exceptions. Yes, that's actually the next slide, Kim.
Sorry. Okay.
It's okay. It's okay. I appreciate the enthusiasm. It's awesome. All right. So we did the try and except block. Now raising user defined exceptions, right? So most of the time you don't need to raise a built-in exception. You can just define your own, right? We raise an error here in the else statement, but you could place this code in function and use a try and except block as well. So you're looking at here, we see a class. It's taking imaginary number error is the name of the class, but there's something here in this class that we have yet to see. Open close parentheses after the name of the class. And what that is essentially this class is inheriting from a different class. Well, Roger, what is inheritance? You haven't taught us that. Yes, I have not taught you that. Now that will be taught more in depth throughout the immersive program, but I will give you a quick talk about what exactly is. Inheritance is exactly what the word means in English, right? We're inheriting from somewhere else, right? The same manner that you, Gary, you inherited your awesome beer genes from your father, right? He passed it on to you, and now you're able to use that. Classes can do the exact same thing. They can inherit from other classes and use the same attributes that they have, right? Same methods that they have. And that's what this class is doing. We created a class and we are inheriting from exception. What is exception? Well, we can Google that. Python exception class, built-in exceptions. But a class, the exception class is something that comes with Python as well, and you can inherit from it. Let me see if I can find the documentation for it. But I wonder if I can do it. Maybe if I do it in my code, I can show you. Let's go ahead. Let's remove this right here. We are inheriting from the exception class because the exception class has certain methods that we want to use later on in the program, but we'll talk about that real quick. What happened to my? Sorry, I'm a little I don't know what happened to my slides. They closed up. Stand by. Stand by. Okay. So we do class. Imaginary number error is the name of the class. And then we do exception. Right? I wonder if it lets me highlight class exception. A common base class for all non-exit exceptions. Go to definition. All right, so we can even go here. Can I open this? Let's see, let me. A little out of scope, but where is it at? What method do we have with the exception class? Well, I'm doing some quick research for you guys, so I can give you guys other examples. Well, I guess the best way of explaining it to you guys, by inheriting from this class, the exception class, and create this subclass imaginary number, what what your file, your console is going to interpret this as is it's going to interpret it as essentially an exception, right? You are just kind of telling it's almost like when you convert a string into an integer, you wrap it around the integer wrapper, and then suddenly your console is identifying this. Oh, this is an integer. Or we're essentially doing the exact same thing, right? We're classifying this bad boy as an exception. Hopefully that kind of explains it to you guys in a non-confusing manner. It's gonna expect something within this class, right? But I don't want to pass it through right now. I just want to clarify that this is like an exception, but I don't want to get any error. I don't want to add any additional functionality. So I'm going to go ahead and put pass within here, right? And that's the reason why it's in the slides. We don't want to predefine or add anything crazy to this. We just want to let the computer know, hey, this is an exception. And then they do user input. Oh no, what happened? User input is equal to int input. Enter a positive integer, right?
I believe you used a dash instead of equals.
Thank you. Finally, someone that assisted me when I do a typo. Appreciate it, Owen. Where have you been always? All right. So if user input is greater than or equal to 0, then I want to do final result is equal to user input to the power of 0.5. Else, what do I want to do? I want to raise imaginary number error, right? So I discussed before, by creating this class, imaginary number error, and passing the exception, right? So we can inherit from it. This essentially becomes an exception, a built exception that we created, right? Imaginary number error, that didn't exist. We just made this bad boy, right? And we classified it as an exception by passing the exception class within it. We didn't want to make this anything crazy or make it too complex, so they just pass in pass. You could add some other stuff in here. We don't need to do that right now, so just pass that way. It's classified as an exception, but there's no actual functionality. And notice here that we go ahead and add some code. We create an input variable so we can receive feedback from the user, and then we check if it's greater than 0. If it is greater or equal to 0, then we go ahead and do this. If this does not work, right, we raise an imaginary number error, right? So by running this main.py, we add a number that's always going to fail. We get this imaginary number error, raise the imaginary number error. So it actually raises the issue, right? And then we could go ahead later on and classify more stuff about it. But the main part of this was the fact that we were able to create a custom exception error that we can just have ourselves. If I'm correct, I don't know how to do this. Let me see. Message failed. Let me see if it works. There we go. Message failed, and we see that kind of prints out here as well. But we'll get a little bit more into it. Just stick to class, and then whatever you want to call your error, and then just pass an exception and just pass it, okay? So we'll keep it like that for simple right now. We're gonna build into it a little bit more. We're
Quick
gonna go.
question, Roger, before you move on.
What's up,
With
buddy?
this imaginary number error, do the program still continue with this one, or it still stops in its track because of the traceback error?
That is a good question. It should, we're not handling it, so it should stop here. Right? Cause we didn't do any try except block, we didn't add anything in there. -5. See? We erased it. We manually erased it ourselves, right? In our code. What is different from what we wrote earlier? If we go back in the slides, so I don't have to code it out again. The difference between that and here is that here, right, is we didn't raise zero division error. The try and except block is catching it, right? Whereas earlier we specifically added raise, right? We are raising that red flag. Like, hey, this is the issue, and we're stopping the program. Right here, we didn't raise it, we're catching it, and then we added it what to do when we catch it. We can do that here too in our code as well. When we raise it, we can, and we'll talk about that in a bit, right? But no, it is not continuing on, it stops it. Raised it, and then here we caught it, right? And we'll talk about that in a bit after the outer range.py.
Roger,
Mike.
will you go back to your code real quick?
Mhm.
Got a question on that. So I see you made a class for it, but as I look at it, my wonder, couldn't you do the same if it was just a function? If it's just doing a call in the raise, or does it have to be class?
The class, because we're inheriting from the exception class, it will classify as an except
Okay.
like an error.
See. Okay.
And then, well, like I said, we're able to, we can customize this even further. We'll talk about that in a bit.
Okay. That I missed that part. You're inheriting. Okay.
Mhm.
Thank you.
No problem, brother. Yeah, once again, just discussing that. We saw something different here, where before we were creating classes like this, right? Class, imaginary number error, it was nothing, right? We just created a default class. Here we open and close parentheses, and we inherit it from the exception class. We're taking in the functionality from the exception and classifying this as an exception. We're not initializing anything right now, so we don't really have access to any of that stuff yet, but just know that this is essentially considered an exception.
Got it. Thank you.
No problem. All right, out of range.py. Let's see. Out of range.py. All right. Define an exception out of range error. Write a function named name the number that asks the user for an integer. And if it's equal to 1, prints 1. If it's equal to 2, prints 2. And if it's equal to 3, prints 3. If the parameter is one of those three values, the function should raise an out in range error. I'm sorry. If the parameter is not one of those three values, then it should raise the out of range error. Write code that calls name the number in a try block and handles the possible out of range error in an except block. It should handle an out of range error by printing that is not one of the allowed values. right? So essentially you're combining what both of those examples we did earlier, right? You have to create an exception, right? Just call it out of range error, right? And then your actual code block should be the try and except block. And then you have to manually erase the error and also catch it, right? Give it a try, and then we'll see how you guys did. This is not gonna be too long, so we'll take about let's say 10 minutes, and then we'll go over it. Sound good? All right, let's go ahead and come back, and we can talk through the assignment. Okay. All right, so the assignment is called outer range.py. Let me share my screen. All right. So essentially we had to define except. What's up? What's that? Everybody good? I'm sorry, maybe I hear like an echo or something in the background. I'm not quite sure.
It was
All
just someone had their mic off, or their mic
Okay.
on.
I'm sorry. All right, let's go ahead and continue then. So we're gonna go ahead and define an exception named out of range error, right? So class out of range error, we're going to inherit from the exception class. And once again, we're gonna put pass. We're not gonna do anything right now. So the reason why we're not getting into actually, doing stuff within the out of range error class is inheritance, and honestly the pillars of object-oriented programming. It's a little out of scope right now. That'll be taught to you guys in the immersive program. But when it comes to inheritance, polymorphism, abstraction, and just everything that goes into object-oriented programming, just know that you're able to inherit from other classes, right? You're able to use their methods by initializing the parent class within its subclass. But since it's out of scope of the foundation of programming, I don't want to cover it. The only thing you guys need to know about this ever class that we are creating is by inheriting from the exception class, we're able to kind of just define this class as an exception, right? There's other error handling classes we can inherit from. Just know the exception is the more standard and common one you'll see. And then we're just putting paths because we don't want to get any errors here. We are just defining our own custom-made exception, and that's it, right? We'll keep it very simple. Now, we're going to go ahead and define the function that we were supposed to create called name the number. So we'll do define name the number. Ask the user for an integer. It doesn't take any arguments. So we're going to go ahead and start our try and except block, right? So one thing I want to talk to you guys about when it comes to the except block, try and except. When you use a try and except block, you want to use them sparingly. And the reason I say that is if you start using or doing all this code in your try and except block, what happens is if at any point within your try block, something goes wrong, that try block will fail and it'll go to your exceptions. So if in your try block, you are accessing different dictionaries, grabbing different keys and values, you're doing for loops, and you have all this code and you just started coding it, you're not quite sure, especially as brand new coders, you might run into errors. More than likely you will run into an error. And what's going to happen is you're going to find it very difficult to find where in that try block that issue occurred, right? Because it could happen on the first line, it could happen in the middle, it could happen at the end, but it won't be very specific. All you'll know is that you're getting whatever is in your except block, right? So unless you're very specific about what the exceptions you're supposed to be getting, if something goes wrong, if you built in the errors that are supposed to be raised, if as beginner coders you guys start using try to except blocks for everything, and you have all this functionality within your try block, you might find it a little difficult trying to debug it. That's the only disclaimer I want to give. So use them sparingly when you guys first start off, and then as you guys get better, you can start implementing them more into your code, and use more, error handling more efficiently, right? So that's the only disclaimer I wanted to give before I move forward. So within our try block, we're supposed to ask the user for an integer. So we're going to create a variable called number. We're going to assign it the input, but we're going to wrap it around integers so we don't get any weird functionality here. And then we're going to ask it what as user for an integer. So enter a number, and then we'll give it options 1, 2, and 3. Right? Now, after we get a number, we're gonna say if the number is equal to 1, what do I want to do? If it's equal to 1, print 1, equal to 2, print 2, right? So if number is equal to 1, print 1. And if number is equal to 2, print 2. Elif. So what is this, Owen? Well, it's an else if statement, but we have multiple options that we can run into, right? If it's 1 or else if, right? That's what we're saying here. By using elif, we're essentially saying else if it's 2, then do this. Else if number is equal to 3, then I want to print out 3. Right? Now, in the event, right? In the event it's not 1, 2, or 3, I want to do something, right? So this is where the else will come in. Else, I want to raise out of range error, right? This is where I'm going to raise that error. So I need to be able to grab either 1, 2, or 3. If some knucklehead decided to put 4 because he didn't read the instructions, then I should be able to read or raise out of range error. And then within my except block, I'm going to do except out of range error, right? So I'm raising it and then I'm catching it, right? So these, at this point, nothing should go wrong here because it should be an integer, and I'm just checking whether it's 1, 2, or 3. And we're catching if it's not 1, 2, or 3, and we'll handle the integer thing in a bit, whether it's a value error or not. So except out of range error, and then it should raise the error, and I just want to print that's not one of the allowed values, right? And then put an exclamation mark because we're yelling at him. Now, let's go ahead and try this. We'll do name the number, and let's run it. Enter a positive integer. Let's do 2. What the heck? Where did I put hello? Am I crazy?
That's kind of scary.
Oh, I'm running Python main.py. My bad. I was like, what the heck is going on, dude? CD lesson 09, CD out of range, and then Python. All right, there we go. Enter number 1, 2, 3. We'll do 3, and we see here it prints out 3. Now, what did we add? 4. Notice that's not one of the allowed values. So when I added the 4, we didn't see it, right? Because we had the except block, right? But we did, we raised the out of range error. So that red flag went off. And because we raised that error, that means our try block failed. And we went to the except block. It grabbed the out of range error because we had defined it. That's the one that was raised. It found it. And it prints out that's not one of the allowed values. Right? Now, what happens if I add 4. I typed out 4. I get value error invalid literal for int with base 10.4. So obviously they can still mess this up. Well, we can also do something like this. We're going to do try, name the number, and then we'll do accept value error, right? And we get the value error. I want to say, please enter a valid integer. Runs again. We can check 4. We still get the same out of range error. Now let's type in 4. And we see, please enter a valid integer. So we were able to define our own error, right? We raised our own error. We caught our own error. And then we also caught a value error that's a pre-built error already. So we were able to do both, right? I wonder, I'm pretty sure we could do, can we accept value error, print, please enter a valid integer. Let's get rid of this, name the number, 4, 4. Okay, so what I just did, I just reformatted and I added all within the function itself. We create our own error, which is out of range. We were able to catch that error. But let's say it fails not because out of range error was raised, but the try block failed. Where did it fail? It failed here, right? It failed here. It never even got to raise line 14. But when it got here, because we added a string that couldn't be converted to an integer, this wasn't properly saved. This raised the value error on itself. So down here, we did 2 accept blocks. One was able to catch the out of range error if this happened.
Is he talking
we
for
also-
anyone else?
What's up?
Yeah,
No.
Can you guys hear me? Hello? Hello?
Now,
He's
Yep,
back.
there you are.
Oh, I'm so
Welcome
sorry.
back.
It says your internet connection is unstable. I'm sorry, dude. I'm running on potato Wi-Fi right now. All right. I must have left my window open. All my Wi-Fi is getting out. So, all right. So what I just did here, I don't know where it was last thing I said, but essentially we moved the try and accept block that we did here within the name the number function, right? It never got to line 13, right? Where we had to raise the out of range error. It raised an error here. Why? Well, when we got to line 6, the try block failed because we tried to give it the word 4. It couldn't save it here because when we tried to convert the string 4 into an integer, it failed. It raised the value error message, right? So what we did down here is we added 2 accept blocks. One was to catch the out of range error in the event we added something that wasn't 1, 2, or 3. But we also added this block here to catch the event where they might add a string and the try block fails here. Right? So this is the exact same as this. Please. Right. These are the exact same things. Right? One, I did it here, where the other one, I caught the value error within the function.
Mike, you got a hot mic.
Yeah, Mike, mute yourself. Right? So both are the exact same thing. One was a pre-built error that we defined, and then we were able to catch a second error that we didn't define that was already pre-built with Python. And we were able to catch both. Cool. Good stuff, guys. Good stuff. So that's how you're able to handle exceptions, how to keep it from stopping your entire program and moving forward. Do I have any questions here? All right, time is 7:59. We are going to take our last 10-minute break of the night, and then we're going to finish off today's lesson with unit testing. Go ahead, take a 10-minute break, and we'll be back at 8:09.
Can't hear you, Roger.
Thank you, and appreciate it. All right, guys, let's go ahead and come back. Finish today's class. So we just finished out of range pi. That'll conclude the exception handling part of it. The last thing for today is going to be talking about unit testing, right? So unit testing refers to testing individual units of code to make sure they work correctly before integrating them with your larger code base, right? Most places, when you guys get your job, is going to work around code that is test driven, right? So it's important that you guys get familiar with unit tests and how they work, as well as, for your first gate, which is the immersive program, all of your modules, not your modules, my bad, all your assessments, you will be given a file within your assessment that'll have pre-built unit tests that have been created by our instructors, right? You have your README, your instructions, and you will go through, create your program for the README and what it requests from you. And once you're complete, you will run your unit tests against your program. And we're going to do that today too, so you guys can see how it works. And that's how you will be graded, right? You'll be given a certain amount of unit tests, depending on the assessment. Some have more than others. The PostgreSQL one was probably the shortest one. I don't know if it got updated, but when I went through, it was like maybe 10 unit tests. Maybe Brandon give you more update information if they made it harder. We all think the PostgreSQL one was probably the easiest one. Your assessment will probably have somewhere between 24 unit tests. And they'll tell you how many you have to pass from all of them, right? Typically about 80% of your unit tests need to pass. 80 to like 70%, somewhere around there. And you're going to be essentially forced to learn how to handle these unit tests, right? If it's your first time seeing them, it might be a little overwhelming, as I've talked to you guys in previous classes. But this will allow you to kind of visualize what the unit tests are doing, and kind of be able to read the unit test, right? So if you are having difficulties running your test and trying to understand the error messages you're getting back, sometimes it even helps just kind of go into the unit test. If you understand how they're built, you can kind of understand what they're looking for. And after today's lesson, you'll have a much better understanding of why that is, right? So lots of modules available in Python for unit testing, but we will be using unit tests, right? It's a module like everything else that you guys have imported. This unit test module defines a number of assertions that can be used to verify whether a certain condition holds. There's a partial list on the next slide. And as the slide says, it's okay if this doesn't make sense right now. Examples are coming. So don't worry about it. It's actually very, very simple. The ones that we're going to be creating today are super simple. But it'll give you a rough understanding of how unit tests work. So what are assertions? All right. So assertions are what you essentially use against your code, right? So they're very self-explanatory by the name. You can see here, assert equal, assert not equal, assert true, assert false, assert is not in, almost equal, and not almost equal. Notice that all these methods take certain parameters. Obviously, for assert equal, you're probably trying to compare two different values, which is why it takes two arguments, A and B, and you're trying to check between both of these arguments whether they're equal or not, right? Asserts that A and B are equal, right? Essentially, these methods are testing the parameters that you pass in with each other, right? If it was a Boolean, you see here, it passes an argument and it checks, hey, is this Boolean true or is it false, right? If it's supposed to be true, and it's not true, then you will get the error from your unit test. And same thing for everything else, whether it's equal, not equal, so on and so forth, right? You guys are free to check these out. There is a lot more than these. These are just a partial list, are the most common ones you probably see. But let's look at some of these code snippets, right? So writing unit tests. So first and foremost, you're going to create a test file. And you're going to import the unit test along with the file/functions you want to test. Here, we see we have two files, main.py and listfuncs.py. I'm sorry, I burped. Right. The listfuncs.py is holding a pre-built function here called listmax. It takes in a list, very simple, and returns the max list, right? So it turns the max number within this list, right? Owen, if you're not familiar with some of the methods with Python, it's one of the more basic and common ones for Python, where you can pass in a list within the max method and it'll return to you what essentially is your greatest number within that list, right? Next, you're gonna create a class that inherits, right, from the unit test.test case class. All right, we'll cover inherits at a later date. So notice over here, our main.py is actually our test.py, right? Our test folder, our test file, I'm sorry. At the very top, we're importing the unit test module, just like we imported statistics. All right, just how you guys imported the random. It's just another module that comes with Python, importing unit tests. And then from the list functions, we are importing the functions we want to use. We only have one function, which is listmax, so we import that function so we can run it within our unit test. We then create the class. Actually, let's go ahead and code this along so we can kind of get some muscle memory in here. So I'm gonna move my slides to the side. Let's go ahead, go to our lesson 9 file and make yourself the lesson 9 folder, make yourself two files, one being main.py and one being functions.py. All right, let's go ahead and create within our functions.py this small little function, which is define list max, which takes in a list. We'll put li and then return max within whatever list is. Right. Very simple. Within our main.py, we're going to import unit test. Right. Unit test, and then we're going to import our module from functions import list max. All right, so far everything's still the same as the slides. We're gonna go ahead and create our class. And it's gonna be called test list max. All right, what you call this class doesn't really matter yet. What matters right now is what you inherit from. So ensure after you create your class, you're going to open close parentheses and we're going to inherit from the unit test. All right, we're going to do unit test dot capital case test case. Right. So exactly like this is how we're going to inherit from the class test case. And the reason why we inherit from the unit test class is because we want to use their methods that comes with the class. Right. These methods are the assertions, right? Assert equal, assert not equal, assert it false, right? True, yada, yada. So that's why we have to inherit, so we can use their methods. Next, we're going to go ahead and define our test cases. So we're going to do our very first test case here. We're going to define test 1. Notice, right? The function names can be whatever you want. Was I losing here? No, okay. Now we're still on the same track, right? The function can be whatever you want, right? So it's gonna be test 1, open and close parentheses, and passing stuff. All right. Next, we're gonna test whether the list is all positive values, right? So we can add some comments here. When you create your test, it's obviously very important that you add comments here so you can read the test to see what they're doing. The comments here is test a list of all positive values. Right. And here is where we kind of make our examples. We're going to create a list And this list can be whatever you want. We are the ones creating these test cases because we know that, hey, our function needs to be all positive numbers, right? Right, all positive numbers. If you know that the function that you're creating has to have a certain way that it's supposed to work, as a developer, the way that you will create your test is to test what it should be doing. And obviously, if it's not doing it, your test will fail, right? And in this situation, I want to make sure that this method is supposed to only have all positive numbers. It should work with positive numbers, right? So a list is equal to, and I'm gonna create a random list here. It's gonna be 6, 43, 18, 100, 9, and 85. Next is actually getting the result, running our function. So result is equal to, and then we're gonna call the function we created list max, pass in the new list we created, a list. All right, so we're actually gonna run the function that we're trying to test, right? And we should be getting a result. And here is where the actual assertion comes to play. You do self dot assert equal, and then it takes into parameters, right? If you guys recall from the slides, right? Assert equal takes A and B, asserts that A and B are equal, right? So this is where it actually tests our function against the right or wrong answer. So it should be able to take in result and a list, and then what you call it, that's it, right? And let's see how that works. So at the very end, we'll do one test case right now so we can kind of get the hang of it. At the very end, we're gonna do what we covered earlier in today's class, where if underscore name is equal to main, then I want to run main, right? Now, what's gonna happen when I run this, right? It's gonna run through my console. Why is it running through? Why is it running the way it is? Well, because we're checking, hey, does name equal to main? If it does, that means we ran the test individually, right? We ran it as the script, so it's gonna run our unit test. And we see here within our console, we get some feedback. We see fail test 1, right? Notice that the documentation that we added is actually within our test. Test a list of all positive values, right? So this gives the description to your test case, and it'll even show you when you actually run the unit test, what that unit test was doing, right? Because we're good developers, we added documentation within it, right? And then we get the actual test being ran, right? We see on line 10 within our main.py, our test file, in test 1, right? It tells us what test it was. It tells us what assertion it ran, self.assert equal. It took in result and a list, and we see that it does not equal what it should be equaling, right? So it failed. Well, why? List max. It shouldn't have failed actually. Test a list of all positive values. It took in the list. The max is 100. Result. Oh, I'm sorry. I'm dumb. I'm dumb. Okay. Why didn't it work? Well, because I did the assertion wrong. All right. So when we ran the assertion, we got result. What's result? It is what you call it, the list max function. So you ran the function. This will return to us 100, but we have to run it against something, right? Obviously, because we're creating this test, we know what the right answer should be. By looking at this list, what's the answer? What should be the answer from our function if it's supposed to work?
100.
100, right? So result should equal to 100. So this is how we compare it, right? We created our function, which is supposed to give us the max of a list. We see here that this is 100, and what you call it, we put in 100 right here, and it compares them together. So when we run this, it should run, and if we get an okay, that means everything was successful, right? The list will work. Does that make sense? It tested if the number was supposed to be right. Now, let's see if we messed up our function, right? We're a little slow and didn't understand the concept. Like, it takes us a while to understand this. Like, I'm still learning min max and all that stuff. And I was supposed to create a function that's supposed to return to me the max value of a list. But when I coded it, I accidentally put min, right? So the function doesn't work. But my intent was to create a function that returns to me the max value within this list. So obviously, when my test case is being created, what am I testing it against? Well, what's supposed to be the max value, right? So I make something that I know it's supposed to come back as true, right? I know 100 is supposed to be the correct value, right? So I run my function. Result should be 100, right? So we're testing the result against what the correct answer should be. And when we run it, it fails. It says assertion 6 does not equal 100. Well, why? What the heck, 6? Like, I know it's not supposed to be 6. Like, my function was to get the max of this list. It's supposed to be 100. So then I go back to my code. Oh, I messed up. I added min instead of max, right? And then I go back and I fix my function. That's how my test cases helps me see where my code went wrong, right? It showed me what my code actually did and what I tested it against. And I can go back, well, why am I getting 6 when I'm running this function? Like, where is this giving me 6 if I was to have this test case right here, right? And I figure out I use min instead of max, right? Let's go to another example. Make sure we're all understanding this. We're gonna go ahead and create test 2. Test 2 self, right? This is gonna be to test a list of all negative values, right? So I'm gonna create a list. I know what the right answer should be. So -1, -4, -10, -2, right? Result is equal to list max a list. And then what is the max value for these negative numbers? What's the highest number here? Right? If my function is supposed to return to me the max number within this list, and they're all negative values, what's the right answer here?
-1.
It should be -1, right? If my function is working, it should give me -1, right? So then I do self dot assert equal. I'm going to check that my result. Oh, I added -1 to the wrong area. My bad. Result is equal to -1. So it's gonna test if my code works, right? It's gonna check if it gets me the max number from this list of all negative numbers. I run it, and Oh, my bad. I added two test ones. Test two. There we go. So here we go. So I failed two tests. Why am I failing two tests? Well, on test one, where it's testing all positive numbers, it's supposed to return to me 100, but I ran 6. We covered that already, right? Because I added min. On test two, when I tested it with negative numbers, it should have returned -1, but it returned -10, right? Because the min, if I was to use the min on this list, it would return the lowest number, which is -10. So notice that I failed both these tests because my function is wrong, right? My function is wrong. Now let's create something a little bit more complex, kinda, right? Let's go ahead and create a class here. We'll call it dog. Define init self. It's supposed to take in, let's say the instructions on your assessment says, hey, you need to create a dog that has a name, breed, and age, right? Name, breed, and age, right? But you misunderstood, right? You didn't read the instructions right. So you created this class that says name, color, and age, right? You misunderstood the assessment. You're a knucklehead, right? And you created it. You added self dot underscore name is equal name. Self dot underscore color is equal to color. Self dot underscore age is equal to age, right? Now let's go back to our main.py. Let's go to test one. This is going to check dog created instantiated a dog object, right? Well, it should be, how can I do this? Dog one is equal to dog. Let's go ahead and import our dog class from functions, import dog, right? We're gonna create the dog object here. The dog, it's supposed to have a name. We'll call it Fido. It's supposed to have, let's change this so it can make sense. Breed and color, right? It was supposed to be name, breed, and age, but you understood name, breed, and color, right? So we can test it against an integer in the string. Name, breed. And give you guys an example of how your assessment's going to go, where you misunderstood something and you didn't create your class like it should be, right? You created with name, breed, and color, but it's supposed to be name, breed, and age. So in your test case that you're going to have, that's going to be ran against your code, it's going to be something like this, where it's going to be Fido. He is a pit bull, and he has an age of 2 years old. So an integer is passed in, so it can test your object, right? And then we're gonna do self dot assert equal. I believe this is the one to use for this. And we're gonna say dog one is equal to blah, 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 blah. How can we do this? Dog one. Let's see. How can we test? Let me look at the test case real quick. So essentially, we need to see if did your dog one get instantiated, right? So we create the class and then the unit test. Let's see, what unit test do we use? Assert if instance, I think is what it's called. Okay. Now let's see. Okay, so we can do self assert is instance, and it should take in the object I created, which is dog1. It's going to take in the class, which is dog, and then if it fails, it should give a message. This is just one of the assertions you guys can use. It takes in A and B and then a message of why it did not work. Object is not an instance of dog class. Right. This wasn't on your slides, but I'm trying to test on classes, right? Assert is it's gonna check if, and you can see here when I hover over it, it tells you how the definition works, right? The first parameter it takes is the object, right? So we create the object. The second argument it takes is the class, right? So the class info. So we pass in the class info. And then the second one is a message. You could leave it to none, but obviously a good unit test should tell the user where they went wrong. So let's check it out. What the heck? It did it wrong. Object is not instant class. Where did I go wrong? Let's see. What did we do? This should be. I'm trying to give you guys an example so y'all can understand. There we go. Let's run it again. What? Dog1. It grabs the dog class.
Are you trying to force the error?
Yeah, I'm trying to force the error.
You could wrap that in a string, right? STR color.
Yeah, I'm trying to see if this works. Okay. It's still passing.
It'll work if you do the reverse. If you put an int there, and then wait, I'm thinking of the
No.
input function.
But shouldn't it
Okay.
still be passing anyway because it is an instance of the dog class?
It is. So I guess we can probably do self dot assert equal. We'll pass in dog1 dot name. And then it's a private data member. All right. I'm accessing it directly for instruction purposes. All right, just so you're aware of that. I don't want to do get methods right now and make more code than I already have. We're going to check if the dog name is equal to let's go with Fido. And if it's not equal to a string, we could say the name attribute is not a string. Right. Now let's check assert equal. Let's go ahead and check the age just so we can get done with this. Age, and then we'll pass in it should be age. What do we do here? So the age is equal to 2. And let's see that runs. Okay, there we go. Now it's actually gonna give us the error. The age attribute is not set correctly. All right, so I don't know why this doesn't work, right? But we're checking here the attribute. All right, we checked the attributes directly, and we ran it. We see here we got a message, right? We got test1 failed, right? There's an error, instantiate a object, and then we look at what exactly part of the test it failed. And we see assert equal where they're asserting our the class age, and it's supposed to be checking whether it's 2. It says the age attribute is not set correctly. Attribute error, dog object has no attribute age. That means, okay, by reading this, I see that my dog object is supposed to have an attribute called age. And then I go back to my function, like, oh, I misunderstood this. I put color, not age. Does that make a little bit more sense? I'm sorry, that took forever to do. But do you guys understand how this works now? Maybe actually troubleshooting that gave a much better example of what these test cases are doing. I don't write test cases on a daily basis. Let's just go ahead and put that disclaimer out there. But essentially, I was given the instructions, right? Just like you will be given on assessment, or just like when you guys are creating a project, you know what the function is supposed to do, but somewhere along the line, either you got confused, you misread the instructions, whether you're in the immersive program or you're coding on your own and you're 8 hours into code and it's 3 a.m. Your wife's screaming at you to go to bed and you just can't focus on your screen anymore. So you put a typo in your class, right? And then at this point, you're probably like, 300 lines of code deep. You have all these classes, so obviously it would take forever to go through and just read all your code. So why don't you just create test cases, right? And you create test cases. When you want to create this dog, what should my dog have? It should have name, breed, and age. But you didn't realize that at some point you added color, right? In the test case, you assert that it's supposed to be doing what it should be doing. And then notice like it gave us an error, right? Because it doesn't have what it should have. And it failed that the test. And that's what's gonna happen to you guys too. When you guys go through the assessment, you will have the instructions of what you have to do and how to build your class. You're probably gonna mess it up. You will mess it up, as a matter of fact. And something's gonna go wrong. There might be something where it tells you, hey, create a dictionary in here. The key should be objects, or it should be the titles of the objects, and the values will be objects. And then the test case will be testing you, but let's say you did it wrong, right? The object wasn't saved as value. You saved the title, and the value was probably like a list or something, and it's gonna check that. It's gonna check whether that list that data member is supposed to have, is it an actual dictionary with objects or not? And you're gonna get an error message, hey, your whatever class attribute does not exist. That means you probably messed it up, or hey, this value is not an object. And by reading those test cases, you're supposed to go back to your code. Okay, so it's telling me I failed like somewhere in my object dog. So you go back to your objects of where you created that class and you look at your code. Okay, well, it says I don't have this attribute. Why don't I have this attribute? And then you fix that, run it again, and then you pass the test case. Does that make sense to you guys of how the unit tests work? And they're gonna be very similar to this, right? All you have to do, they're gonna be in the exact same folder as your assessment. All you have to do is just run that test file. The stuff should already be imported. The file should already be ready for you. Everything will be ready for you in that unit test. It should already have what you should have already declared. It's going to tell you how to declare your functions. It's going to tell you how to declare your methods, what it should be called. And if you call something different, it's going to tell you that this method does not exist. This function does not exist. This class does not exist, right? This class is taking the wrong arguments. Does not have this data member, right? This value is the wrong value. And then you go back to your code and you look for that issue and then you solve it, right? Okay, sorry. I feel like it's better if we just learn that way than just showing you the slide and you read the slide. All right. So inside the class, you define your test functions with the appropriate assertions. Notice I had to mess around with a little bit. There's different assertions you can use. We saw a partial list, but there's a lot more. You saw the assertion for the instance one, and there's a lot more out there. So if you guys ever have to use unit tests, you can look at the Python documents, check out the unit test module, and you can find a list of those and kind of mess around to see if it's doing what you need it to be doing. You add the unit test main function within your script conditional, right? And then you run your test file with Python name of file. So just like we did earlier, right? We just run it independently. I changed my terminal so it doesn't look all red, but normally if you guys haven't added any customization to your VS Code, it's gonna look red. It's gonna look like a murder scene on your console, right? And if everything passed, you will see something like this, right? All 5 of your tests passed. You'll see you ran 5 tests in how many seconds, and you'll get an okay, right? If something failed, you're gonna get the exact same message you guys saw on my console, where it tells you fail, the name of the test, right? And then what the issue was, what the assertion was trying to check, and how it was wrong. All right, last one. Go ahead, try it out. Make 2-3 test cases, and then we'll finish off the night. Right, multiply that pi. I'm rushing it because we only have like 60 minutes left. So go ahead, give it a try. We'll take 10 minutes, and then we'll call it a night. Sound good? Speed run. That way we can get out of here and enjoy time with our family. So in my multiply.py, oh man, I should have had it pulled up already. Let's go ahead and remove this. I'm going to go ahead and create a function called define, multiply 3 numbers. And all it's going to do is take in 3 different variables, A, B, and C, and then return A times B. And then I'm going to add an issue here, right? Plus C. That's my issue here. I fat fingered my keyboard, and it's going to fail. All right, so we're going to create a new file. I'll call this test multiply.py. And then within my test multiply.py, we import unit test like before. And then from multiply, import multiply 3 numbers. Create our class. We'll call this test multiply function. Inherit from the unit test.test case class. And we can start defining our test case here. So we'll do define test multiply integers taking self. We'll go ahead and call the function that we created and say that the result is equal to multiply 3 numbers. It's supposed to take in 2, 3, and 4. Because I know what this function should be doing, I can assert something to it. So self dot assert equal. And by looking at this, if my function was done correctly, it should be 2 times 3 is 6, times 4 is 24, right? So I should be able to do result and compare it to 24, right? Let's add a quick script on here. So our line of code, if name is equal to underscore main, then I want to run the unit test. So unit test dot main. Right? And then we can go ahead and let's get rid of this. Where am I? CD, we multiply, and then Python test multiply pi. Right? What the heck? Okay, it doesn't know what it's talking about. All right, it came back wrong. It says it ran correctly. Let's check out multiply.py. I did that. 2 times 3 is 6 times 4. It's 24, right? Am I going crazy? 24. And I'm checking whether it was correct. This should return. Uh-oh. Don't look. What is going on here? Who can see something I'm not seeing?
Is it because you did a return instead of using a result in the? Would that change that at all? Like returning a result
No,
instead of?
it would not. Result equals multiply underscore 3 numbers. Self dot. What is going on? Look, if we change this. See, it's what is going on? The instance one shouldn't have worked. This shouldn't have worked. What am I doing wrong? Probably because how was it this? No, there's no way. Oh my god, it was the underscore. Oh my god, why is it like this? All right, I added an underscore right here, guys. My my method, right? I don't know why it.
That makes sense. It does say on the slides that every test has to begin with the word test.
You're right. All right. There you go. Now it failed, right? Notice 10 does not equal 24. Well, 10, why is it giving me 10? That means my function is doing something weird here where it's resulting in 10. So I go back. Oh, I added a plus sign, right? Let's go ahead and create one last test case before the end of the night. We'll do define test multiply floats at self. We'll do result is equal to multiply three numbers, 2.5, 1.5, 2.0, right? And we're gonna do self.assert equal, and then it should take in result. What should be the correct number for this? Quick math. I have it in my notes. I don't know what I'm saying. 10.5. And then we can even say a decimal place. Places equal 5. Don't worry too much about that. But let's run it. It says an error. Why is it not running this one? Or it ran two tests. Okay, it did fail the test multiple floats. Places not like this. Okay, there we go. We run it and we see here assertion error 5.75 does not equal 7.5. Obviously, it didn't do the math correctly. Once again, because I added a plus sign. But once we actually fix our code, we can run it again. We run the code and we pass both tests. I know, fairly simple, right? But this is kind of how they're built, right? You're gonna be tested against floats, integer strings, whether your class actually instantiate an object. They'll test your dictionaries, they'll test your lists, they will test everything, right? So be prepared for that. If your functions, your methods, your class are supposed to return something and they don't, you will get an error and your console will yell at you. But that's all the time I have for you guys tonight. It is 8:59. I will stay here for another 5 minutes if anybody else has questions. But the only thing remaining left on our slide is going to be eliminate stand.py, which we will do. This is probably the toughest challenge you guys will face during Foundations of Programming. But that'll take tomorrow all day. And don't work ahead because you guys are going to be working groups. Or now you're going to be staring at a computer the entire time. So don't work ahead. Cover everything you guys have covered up to this point. And yeah, I mean, you guys have nothing else for me. You guys are free to go. Thank you guys for showing up today, and I will see you all tomorrow.